Alright, today what we're going to talk about is Chapter 1 in the Fast Track book, Research Methods. Now this on the overall for the AP National Exam is worth 8 to 10% of the overall exam. So again, that's going to be 8 to 10 questions. So this is an important chapter. This is one that you want to make sure you understand some of the fundamentals that we're going to talk about, which again is really research design. Now, critical thinking is researching with factual information to arrive at a conclusion rather than assumptions. Remember from Chapter 14 that psychology is separated from philosophy simply from the fact that philosophy assumes and speculates, whereas science, which psychology is under that domain, questions in terms of researching and using factual information. Now, some of the background information that you might have seen in other classes. Psychologists use hypotheses. Now, hypotheses is an educated guess. It's basically an if-then statement. If so-and-so does this, then so-and-so is going to experience this. Okay? Now, operational definitions is how each variable in an experimental design is going to be measured or used. And this, when I get to this, is referring to the independent as well as the dependent variable. One variable is going to be manipulated, variable of interest. The other variable is going to be used as some sort of measurement. But clearly what an operational definition does, it provides precise instructions or directions to how an experiment is going to be run. This is important for replication. In other words, so another psychologist can look at the operational definitions and then simply do the experiment themselves. You have to always remember experiments are often used in competition. So if someone finds something, someone else is going to do it from a neighboring competition to see if they get the same result. Now, a theory is an explanation of the recorded data. Now, where some students, get confused on this is an hypothesis is a testable prediction that's simply done before the experiment. A theory is an explanation that is the summarization of the data after the experiment is run. Okay? Now, in terms of some overall background, and this is kind of across the board with most sciences, psychologists have 4 goals in mind: to describe a phenomenon, to predict some future event, to have some control in some future behavior, which often is trying to eliminate behavior or suppress it, for example stress, or explain how and why a phenomenon occurred. The how and why is what draws people's curiosity. They want to know why they do things or how things happen. So psychologists are always simply looking at human behavior. And that's why psychology, a lot of what they publish is interesting because it explains certain things that affect you and I on a daily basis. Now, descriptive studies, which we're going to talk about on the next slide, are aimed to describe behavior. In other words, these are like court reporters. These are people that go out and simply watch what other people do and then report it back. A lot of times where descriptive studies are important for people that are reading them is it often shows that there's more than one person actually doing it, all right, or actually performing a behavior. Now, this chart right here is kind of the blueprint for several different types of research methods. Now, the first 3 are descriptive studies. Naturalistic observation is simply what it means: watching people or observing people in their natural environment. Now, this is good to a point. Naturalistic observation, the drawback or the disadvantage is, once a person or an animal or anything else being observed know they're being observed, they're going to stop performing naturally. For example, if somebody set up shop in this class with a video recorder, you are not going to act the same way or act naturally than if they weren't here. So the minute the observer gets spotted, okay, it's no longer naturalistic. So a lot of this has to be done without the knowledge of other people watching, which then again it brings in ethics sometimes. Okay? Now, case study is an in-depth study of a single individual or a rare phenomenon. Notice it says case study. All right? It's only over a few. It's not going to be simply over a lot of people. Now, Sigmund Freud used case studies. He was particularly interested in studying people in depth. Now, what's the advantage of this? Is obviously you concentrate solely on them. Now, these are people that often tell other people's life stories. A lot of times who's studied in case studies, are obviously people of infamous backgrounds, serial killers, or some people that have done rare things. Now, the problem with a case study, and you're going to see this on several assessments, is that case studies are atypical. And what that means is they can't be generalized to the entire population. They're unique people. So again, they're solely about a single individual. All right? But again, they cannot be extended to a large group of people. It's kind of like a yearbook. A yearbook is not a good yearbook if it only has pictures of one person. Because most people are going to say, well, that's not how our school is. In other words, it's not a good depiction of the rest of the people in the school. Now, surveys, okay, are very good for giving to large groups of people, and they're quick. All right, you give a survey to 40 people, within 4 or 5 minutes, you're going to have the opinion on whatever you're surveying them for. And let's say, for example, it's study habits. Now, you can quickly give the survey, get it back, assess the data, and you can come up with numbers. You could say, based off of the survey, 46% of all kids study directly after school. 50% of them study at night. Now, like I said, they're good for large groups of people. The problem with surveys, all right, and most people probably know this because most of you have taken a survey, you're not completely truthful a lot of times. You're often answering the questions in the way that you think you should answer. All right, and what that's called is the social desirability effect. You are going to answer these questions that are going to make you look socially desirable. So if there's any questions, especially questions that deal with alcohol, tobacco, or drugs, most people, even though it's anonymous, are not going to be honest because of the moment, once they say yes, it's kind of like they're admitting guilt that they actually do it. It's evidence. And most people in their minds will never say they do it, or do a drug or an alcohol thing until basically they put it on paper, then they are reminded of it on a daily basis. Now, correlational studies examines relationships between 2 or more variables. Most common correlational data is, a lot of times there's studies between like smoking and lung cancer. All right, those are 2 variables that they're trying to show a relationship. In other words, the relationship is going to be, if you smoke, then there is simply a higher chance that you'll develop lung cancer. They're trying to show some connection. The one thing that you have to always remember with correlational studies is they do not provide cause and effect. If, for example, with my previous example, if you say smoking increases lung cancer, that is correct correlational, types of wording. But if you said smoking causes lung cancer, that is simply incorrect. Now, the reason why you can't say that, most people would say yes, but it's pretty clear that it does. The problem is there can always be another factor besides smoking. There could be, for example, someone's got a history of lung cancer in their family, so there could be a genetic reason. It could be where a person grows up, like in an industrial area, like an environmental factor. So in other words, you have to use words when you use correlational studies. May increase, have a higher chance. You will not be able to say will cause because of what I just said. There could be another factor. Now, experiments are the only type of research design that are established to accept cause and effect relationships. Okay? They are simply isolating a variable and then measuring the effects of that variable. Now, experiments overall provide causation between the variables. That's their advantage. The disadvantage is it's still, when you do an experiment, you're doing it in a laboratory setting. A laboratory setting is not real life. So that setting, sometimes will affect the way people act or affect the way the people perform because they are being studied. The other drawback of an experiment is confounding variables, which when we talk about that, are variables that can affect an experiment that were simply just not ever considered. Give you a quick one right now. Let's say, an experiment's being done on running shoes. Well, let's say that day it's a very windy day. Now that's a confounding variable, the wind. Nobody counted on it to be windy, okay? And so obviously that's going to affect the results. Now, typical question, just to assess to make sure we're understanding this. Professor Glanlin is interested in studying the effects of caffeine on the aggression level of rats. Which of the following research methods would be most useful in researching a cause and effect conclusion? Now, cause and effect is the key there. Is it a case study, experimental method, naturalistic observation, a survey, or selective breeding? Now again, cause and effect is always going to be the experimental method. None of the other ones can establish that, not even correlational data. Now, Dr. Sanborn, another question, is interested in studying people who have sustained brain damage after ingesting banana peels. Over the past 5 years, he has studied only one patient. Which of the following research methods is Dr. Sanborn most likely using? Now the key in that question is one patient. He's studying one individual. Now when you look at it, is it naturalistic, experimental, survey, case study, or twin studies? Now, the answer is D, case study. Case study is an in-depth interview or study over a single individual or a very few amount of people. Okay? Now again, the problem with case studies is they can't be applied to the general population. In that particular example, how many people actually had brain damage from banana peels? Probably a rare amount of people. Now, this chart right here obviously has a lot of information on it. This is one you have to know, the experimental makeup. Now, experiments are the only accurate way, like I said, to prove cause and effect. Independent variable is the variable being manipulated. How you remember this is independent, IN, is what the researcher is interested in. That's what they're interested in. The IN, okay, the independent variable, that's their interest. They want to know, for example, and I'll use this example. They want to know, for example, do Nike shoes make you run faster? Let's stick with that example. Nike shoes is the interest. So that is your independent variable. That's what you're looking at. That's what you're examining. Now, this word right here, manipulated. Manipulation means to change. So what you're going to do is have people wear Nike shoes that have never worn Nike shoes before. In other words, you're manipulating them. You're changing them. Now, going back to one term we talked about earlier, hypothesis. If-then statement. Whatever follows the word if is your independent variable. If someone wears Nike shoes, then they will run faster. Now, what follows the then word is the dependent variable. Now, how I like to teach this. The dependent variable depends on, notice the word depends, on whether or not a person wore Nike shoes. So in other words, in that hypothesis, if a person wears Nike shoes, independent variable, then that person will run faster. The faster is the measurement. It's the speed. That's the dependent variable. It's the measurable outcome. That's the dependent variable. So the independent variable is your variable of interest, what you're interested in. Now, one quick example. If you said something like, if somebody drinks a Red Bull before they take a test, then they will score higher. In that example, what are you interested in? What are you telling people? You're telling people if they drink Red Bull, they'll score better. So the Red Bull is what you're interested in. Now, how are you going to prove to people that simply the Red Bull is going to affect that the way that they study is their test scores? So the test scores is their dependent variable. That's the variable of measurement. It's what I like to call is the proof. Okay? The proof is simply what you're going to tell people. If you said Red Bull will make you study better, someone eventually is going to say, well, prove it. Well, if you can say, well, look, this person drank Red Bull and they scored an A on the test, then simply that's the proof that they're going to take. That's the dependent variable. Now, like I said, confounding variables are variables that are not taken into consideration by the researcher, but could affect the dependent variable. Now, here's an example, going back to our Nike example. If you said, your hypothesis was, if somebody wears Nike shoes, again, independent variable, then they will run faster. Measurement, that's the dependent. What, if you're the researcher you may have not counted on, was the history of that person? Are they a good runner? Are they in good shape? Did they get a good night's sleep? Did they eat a good breakfast? Was there wind behind them or wind in front of them? All those can affect the dependent variables. So the key thing is to know that the confounding variable are variables that will affect this outcome, this dependent variable. Now, there always are going to be confounding variables because a researcher cannot account for human subject behavior before or after the test. In other words, you can't control how much someone's going to sleep the night before or how much their motivational level is going to be when they're running or when they're studying. Okay? And so that's just something that you have to roll with. And that's why there's never, even though, let's say this researcher found that if somebody wore Nike shoes, they ran 20 seconds faster. You always have to take that type of evidence with a grain of salt. Because when you say, well, what if they did this, or what if they did that, or what was the weather like? You are simply bringing up confounding variables. Now, two groups of test subjects, okay? The experimental group is the group that receives the independent variable. You're experimenting with them. That's how you say it. These are the people that you're interested in. Now, what is the purpose of the control group? Very simple. If you say in your hypothesis, if somebody wears Nike shoes, they are going to run faster, you have to have a group to compare those people to. The control group is that group. They don't get the Nike shoes. They don't get the independent variable. So when you say simply this person not only ran a minute faster personally, they were 3 minutes faster than people that did not wear the Nike shoes. That's the comparison, and it makes your argument stick more. This is more evidence. Again, you have to remember, some people don't like Nike shoes. The more evidence you give them, the more you may be able to persuade them to buy this. And that's the whole point of doing an experiment, to change other people's behavior. That was one of the goals of psychology. Now, kind of just a couple sub-questions. Make sure you understand that. Professor Jackson is conducting an experiment on the effects of chalk dust on memory retention. Participants in Group A are exposed to chalk dust for 30 minutes a day, while those in Group B are not exposed to chalk dust. Identify the dependent variable in Professor Jackson's study. Now remember, the dependent variable is the measurement. So which part of that example is going to be a measurement type of variable? Is it exposure to chalk dust? Memory retention? Ability to form mnemonics? The length of time subjects were exposed to chalk dust? Or the amount of time between exposures? Now, if you said B, memory retention, you're right. The dependent variable, so in other words, if someone was exposed to chalk dust, that's the independent variable. How you're going to prove if chalk dust affected them was how much they can remember. By giving them a test. If they can only remember so much, then that means that it obviously affects them. So in other words, you were proving the effects of chalk dust through their memory retention, which we call the dependent variable. Now, I'll give you another question just to make sure. Professor Leonard is interested, now that's key right there. I want to kind of slow you down on that. Interested in studying the effects. Interested, IN, means independent variable is coming. So they're interested in the effects of caffeine. Right off the bat, there's your independent variable. Now, the effects of caffeine on attention. One group of students is administered 100 milligrams of caffeine prior to a 2-hour lecture on the migrating practices of North American geese. Very fascinating. The other group receives no caffeine prior to hearing the lecture. In this study, this is what they're asking. What is the dependent variable? Now, this is how you answer. The dependent variable is your measurement. It's your measurement variable. We already know that he was interested in the effects of caffeine. There's your independent variable. So how is he going to prove the effects of caffeine? When you look back over the question, how is he going to measure it? I think most of you got this one pretty quickly now. The number of times Professor Leonard looks at his watch, the money students receive for taking part in the study, subjects' tolerance levels to caffeine, the ability of students to pay attention to the lecture, the amount of caffeine administered. Now, if you said letter D, exactly. The dependent variable is the measurement outcome, which in this case is how long they can keep attention. Short, long, that's going to indicate how much caffeine affects them. Now, some other examples of confounding variables, put some technical terms to it now. These are things that are very hard to account for, which again, that's your confounding variable. Participant bias, which I call the social desirability bias. Subjects are going to act. They're human beings. They're going to act the way they think they should be acting. So if they're being studied, like for example, how long they can keep attention, probably that day, people, they're going to put in more effort in the classroom because they know they're being studied. It's hard to account for that. Same thing, there's experimenter bias. Obviously, experimenter, let's say for example, back in our Nike example, they're going to kind of, since they're interested in Nike shoes, probably kind of sell it a little bit more favorably. Okay? In other words, researcher bias is you're kind of pushing someone to answer a certain way. And it could be as simple as saying, this is important, or aren't those shoes comfortable? Okay? They're kind of pushing your attitude a little bit. Now, how you can account for confounding variables? You sometimes can. You can try. Double-blind procedure is the most common. Double-blind design. That is an experimental design when the researcher doesn't know who's in the experimental group, which that was the group getting the independent variable, and who's in the control group. So they can't give any favoritism because they don't know who's being tested and who's not. The other thing is the subjects themselves don't know why they're wearing Nike shoes. They don't know if they're being tested for comfort, speed, accuracy, nothing. They have no idea. So in other words, they don't know how to act, which is what we want to do, to eliminate both of these, participant bias as well as experimenter bias. You know, if a participant knew they were being timed in a mile, they're going to run faster. All right, and it's just the bottom line. So if you don't tell them that's going to be, the purpose, then they're going to, probably behave normally. Now, placebo group is another way to do this. You give somebody a placebo group, it's kind of like a sugar pill. If you want to, measure the effects of caffeine, that was one of our previous questions. And some people think when they're taking caffeine that they should be more alert. Okay, it's in their mind. And they know most of these people have histories of what they're being tested on. So they know caffeine is supposed to make you alert. So if you tell somebody you gave them a caffeine pill, they're probably going to act more alert than really they are. Now, you give them a placebo pill with no caffeine in it, you can see if they're acting or whether or not the caffeine is actually making them retain more material. So that's usually the third group, is your placebo group, just to measure the effectiveness between the independent group, the experimental group, and the placebo group. Now, common question here. Researchers concluded that subjects who were given a sugar pill experienced the same results as those who took the actual medication. Now, the key thing is their sugar pill. Right off the bat, that should tell you what the answer is. Is it confirmation bias, placebo effect, double-blind effect, hindsight bias, or participant bias? Well, right off the bat, we know a sugar pill is a placebo. It's a fake pill. So if you wrote down B, exactly right. Now, another question from that slide. Dr. Cho is concerned that his body language might influence the outcome of his experiment. He's the researcher, okay? Which of the following methods would Dr. Cho use to ensure that he doesn't show experimental or researcher bias? In other words, doesn't lead his subjects to answer a certain way. Well, is it sampling size? B, double-blind? C, single-blind? D, case study? Or E, survey? Now again, if you said letter C, double-blind, you're exactly right. Double-blind is everyone's blind. Researchers blind to who's in the control group versus experimental. Subjects are blind to simply not knowing why they're being tested. Another question. In an experiment studying the effects of alcohol on memory, a subject's tolerance level relating to alcohol consumption, in other words, they can drink a lot of alcohol, would be considered what? Okay, now obviously, tolerance level could affect something. Is it the dependent variable? The independent variable? C, confounding variable? D, random assignment? Or E, participant bias? Now, if you said C, confounding variable, you're exactly right. A person's tolerance level means they can drink more alcohol, so they're going to be able to tolerate more alcohol. It's going to affect how much they can remember because simply their body is used to it. That's a confounding variable. Remember, variables that simply affect the dependent variable that researcher didn't consider. Now, you got to select human participants, and this is where some biases occur. First of all, a representative sample is selecting participants from the population. Now, the population is the group being studied. So let's say we want to know, the effects of lecturing on high school kids. High school kids is your population. So you're not going to have college kids, you're not going to have elementary kids, you're going to have high school kids. Population is who you're interested in. Now, if it's a representative sample, then everybody sitting in front of you in this study are high school kids. That means they represent the sample from the population that you're interested in. Now, stratified sample is categorizing the desired target population into more groups of interest. You're stratifying them. So let's say of that original lecturing on high school kids, you put two groups. Female high school kids, male high school kids. You stratified them into two separate groups. Okay? So you can come out, when you do that, you can say 48% of high school kids prefer lecturing. Now that's nice. But then if you said, well, 36% of them were girls who produced lecturing, then you can go further with your explanations. So stratified, samples, I like to say is kind of your bullet points. Okay? Now, a couple of examples that are in addition to research. Cross-sectional sample is selecting individuals from different age ranges within the population. and then comparing the results of these different age groups. These are always interesting to people. So when you hear things like 15-year-old kids versus 13 prefer to, study out loud, you're making age comparisons, and it just helps the reader to understand that older kids, maybe versus younger kids, prefer this. Okay? Now, cross-sectional again is simply comparing two different groups. You do the same with males and females a lot of times. And we love those things. People magazine loves those things. 48% of males prefer, dinner, 38% of females prefer lunch. We always like comparisons. Longitudinal study is another type of study. This is a long-term study. That's where the word comes from. Long-term means you study the same group of people. It's key there, same group, over an extended period of time. Now this is where you start to see, conclusions based on this. Kids, that were hugged a lot in elementary are very good marriage companions later in life. Well, you track these kids. You looked at the kids, they were hugged, in first grade, and then you tracked them all the way until they got married, long term, and you found out they had more marital satisfaction. One problem with longitudinal is they're very lengthy. Obviously, that's, we're talking, 20 years of waiting, to prove your hypothesis, because you got to wait until they get married. Then on top of it, to track the kids is expensive. These kids, people do move. If they moved out of the area, you got to go all over the place looking for them. Now, sampling, it's kind of getting to the point now how you do it. Sampling is overall just selecting participants from the population. So let's stick with our example, selecting kids from high school. Now how do you do it? You can't play favorites and say, you, because I like you, you'll be in my study because I know you'll answer the way I will. Want you to. Well, that's researcher bias. Random sampling, by definition, and I'm sure most of you heard of it, random sampling is everybody within the population being studied has, keyword here, equal chance of being chosen for the experiment. That is key. Equal chance. No favoritism, no hand-picking. If you have 500 kids, then every one of those 500 kids in that high school has a chance of being chosen. Same chance. Now you can do it computerized, which is the new trend. Put everyone's name in a hat. Whatever you want to do, but everyone's name has to be in the hat. Equal chance. Now, sampling bias is when you just go hand-pick your kids. Let's face facts. If you're testing on memory and attention, and you simply look at kids, grade points, well, if you pick the higher kids, you're going to have a better outcome. Now, random assignment, people get this confused. Random sampling is picking kids for the overall experiment. Random assignment is picking people to either be in the control group, which again, that's the group that doesn't get the independent variable, or to be in the experimental group, which is the group that does get the independent variable. Now, how do you do this? That's called random assignment. Random assignment, listen how I say this, is assigning people randomly, that means equal, to either the control group or the experimental group. And again, you do it randomly, there's no researcher bias by trying to play favoritism or seeing which ones or who will answer better and things like that. Now, your sample questions, make sure you understand it. Dr. Millard conducted research that required 50 participants. The first 25 people that arrived on the day of the experiment were assigned to the experimental group. The remaining 25, the people that came in later, were assigned to the control group. Such a method of assignment may influence the results of his experiment, obviously. Instead, Dr. Millard should have used which method of assignment? To put them in the experimental or the control group. A, random sampling. B, random placement. C, random assignment. D, random selection. Or E, random blank. Now to continue, for a short break, if you pick random assignment, letter C, exactly right. Random assignment puts them randomly into either the control group or the experimental group. Now, stats is in this chapter, and it's a part of this chapter. Descriptive stats involve data that are used to numerically summarize or describe the results of the target population. 38%, 2 out of 5, 3 out of 4. You're using numbers to explain what you found, which is easier for people to understand, obviously. Now, 5 types of descriptive analysis: frequency distribution, measures of central tendency, normal curves, and measures of variability and correlation. Now, we'll briefly go through all of those. First of all, let's give a question. What do descriptive stats allow? Allow the researcher to make generalizations to the wider population. Numerical set of data used to describe an experiment. C, are only used in rare instances. D, allow the researcher to control for confounding variables. E, ensure that neither the subject nor the researcher influences the outcome. That's kind of a tough question. If you put B, you're right. Descriptive stats numerically describe the data. Okay? This allows the researcher to quantify the research and does not involve generalizing to the population at large. Now, frequency distribution is gathering data and then arranging the data, kind of organizing it, making it look presentable, easy to understand from, the novice who's going to read it. Now, they usually use a bar or a graph, a lot of colors, and that's how people are able to identify it. They want it simple. Now, most of you know the measures of central tendency. The mean is your average. Okay, it's your average of all your data. So you got 9 numbers, add them up, divide by 9. Whatever the average is, 4.3, that's your mean. Median is that number smack right in the middle. Okay? Mode is the number that appears the most. If you had 9 numbers, you had 5 4s and 3 5s and the rest whatever, obviously your mode is your 4s. Now, question. Measures of central tendency are mean, median, majority. B, majority, median, mode. C, mean, variability, reliability. D, mean, median, and mode. E, validity, predictability, and reliability. Nice rhyme. But the answer is letter D. Again, mean is average, median is the number right in the middle, and mode is that number that appears the most. Now, continuing with stats, normal curves is your normal distribution. It's a nice little bell curve. Okay? Now, measures of variability, range, is your number from lowest to highest. So if someone scored a 3 and someone scored a 90, those are your two extremes. That's your range, from 3 to 90. Standard deviation is the variability, how numbers vary or deviate from the average, which the average is your mean. Now, question. Professor Washburn noticed that her class scores on her first test were between 89 and 14. Professor Washburn is describing her classes: A, range, B, reliability, C, sample size, D, standard deviation, E, correlational coefficient. The answer would be, if you picked letter A, you're correct. Range is from the highest to lowest of the scores. And again, it's your frequency distribution when you arrange it. Now, kind of wrapping it up with correlational research. Correlational, remember, is a relationship between two variables. Now with this one, let's use our smoking and lung cancer example. Now, a correlational coefficient is the number that describes the strength of the relationship. Now, rule of thumb is, you got to know this, people, the closer it is to 1.0, whether it's negative 1.0 or positive 1.0, the stronger the relationship. Okay? So if you have something 0.98, and then another number correlation 0.88, the 0.98 correlational coefficient is a stronger relationship, okay, than the 0.88. Now that does require, obviously, you got to look at all the data and then simply pick the one that's closer to 1.0. Now, positive correlations is when variables move in the same direction. What does that mean? The more you smoke, the higher the chance of lung cancer. Positive correlation. Now, positive correlations can also move down in the same direction. That's what most people get confused about. Positive, they always think is up. All right? So, negative correlation, okay, would be when one goes down, the other goes down as well. Now, negative correlation is when they move in opposite directions. Okay? So remember, positive correlation, they want to confuse you, moves in the same direction. Negative correlation, they move in opposite directions. Now, more a person drinks, the less he or she can remember. One goes up, more you drink, less you can remember goes down, negative correlation. Now this one's an interesting one. Illusory correlation is an incorrect belief, you're wrong, that one variable affected the outcome when it does not have a relationship. So in other words, an illusory correlation is there's no relationship there, but you might think so. This is what we call superstition. So in other words, a full moon, kids act all crazy. Now, that is a relationship. It just doesn't exist, all right? There is no data to back it up. So that number, if there really was some studies done on that, it would not be even close to a 1.0 or negative 1.0. 1.0, obviously positive correlation. Negative 1.0, okay, negative correlation, moving in separate directions. Now, give you a common question here. Recent research found a correlation between the time one spends listening to heavy metal music and the number of books one reads. The correlation, coefficient, remember that's the number, between two variables was negative 0.83. What does this correlation mean? Negative 0.83 now. So obviously, negative correlation. The more a person listens to heavy music, the more books he or she reads. B, the number of hours spent listening to heavy music, the more number of books he or she reads. C, the less a person listens to heavy metal music, the more books he or she reads. D, as the age of subject increases, the number of books he or she reads decreases. E, as the age of subject decreases, the number of books he or she reads decreases. And I'll give you a minute to think about this, because this is a tough question. You're looking at it right now, you got to say negative correlation, move in opposite directions. So you got to look for words like more or less. You should narrow down your choices. If that helps you, then you probably came up with answer C. Now just to go back to what answer C was, the less a person listens to heavy music, the more books he or she reads. Less, more. Opposite directions. That's a negative correlation. And because it's 0.83, a negative 0.83, that indicates the negative correlation. Now, I'll give you another question, the correlational camp. Which of the following is an example of a positive correlation? As the number of hours a person sleeps increases, her violent behavior decreases. Remember, positive people moves in the same directions. That didn't seem like the same direction. B, as the number of dogs a person owns decreases, her violent behavior increases. C, the less sleep a person gets, the lower her grade point average. D, the more a person watches TV, the less she reads. E, the number of reptiles a person owns has no effect on the number of emails she sends. Interesting. Now, again, we were looking for positive correlations. They have to move in the same directions. Less and more are not the same direction. Now, I don't know how you answered, but if you did say letter C, you are right. Positive correlation, they move in the same direction. What was letter C? Right here. The less sleep a person gets, less. The lower, it's going down too, right? Moving in the same direction, that's a positive correlation. Good job. Now, another question here. Which of the following correlational coefficients would be considered to have the greatest relationship and strength? Now with this one, what you're looking for is what's closer to 1.0. Whether negative or positive. Now this is where you got to kind of do the math here, people. 0.78, 0.33, 0.56, negative 0.84, negative 0.14. Again, what's closer? Now I can see some mistakes going to be made here. If you put answer D, negative 0.84, you're right. Now some of you are saying, well, I thought it was plus 0.78. Remember I said negative 1.0 is also a strong relationship. Negative 0.84 is closer than positive 0.78 if you did the math. Now, last part of our lecture here, inferential statistics. Allow a researcher to apply his or her results to the general population. That's the key what we want to do. Now obviously shoe size and height can't be applied to everybody. So some things can be applied to people and some people can't. Inferential statistics, what that means is you can infer to a lot of people. I like to say refer. Now, statistically significant, this is an important one. Results that are not influenced by chance and are valid and reliable. This goes back to our very first slide today, people. Critical thinking. Backing it up with factual data. Factual data is statistically significant. And what we mean is it's not due to chance. So if a study is considered statistically significant, we can assume that, see if you know this one. A, the study has both independent and dependent variables. The study is conducted in a controlled environment. C, all participants were debriefed after the experiment was completed. D, neither the experiment nor the participants knew which groups participants they were assigned to. Or E, there's a relatively small chance the results were caused by random variables. And I think you know that the answer was E. Statistically significant means that the influence of outside variables on the study is minimal, and it was not impacted by the findings. So in other words, it was not due to any chance. This is how it happened. There's no outside chances. Now the last part of this, APA's Ethical Principles of Psychologists and Code of Conduct, the APA, American Psychological Association. Now, there are several things that have to be done. One, participants must provide informed consent. They must sign up for the experiment. You don't go out and randomly pick people and then, shock them. They have to know and be able to give their consent that they're willing to be part of the experiment. They have to sign the line, so to speak. Participants must be debriefed. When they're done, you just don't kick them out the door and say, have a nice day. You got to tell them why you did what you did to them. So you don't scare them. I mean, if you were flashing lights at them for an hour, you got to tell them why you were flashing lights at them. You don't leave them out there and say, oh, I wonder what's going to happen to me because I was, subjected to light flashing for an hour. Now, you've got to be confidential. You can't go out saying if someone has a bad effect and, does whatever during the experiment, you can't go sharing that with your colleagues and having laughs about it. And then no participant can be psychologically or physically harmed. You cannot just cause harm to someone to see what the effects are. And that concludes our lecture today. Remember, this is chapter 1, 8 to 10 questions on. You got to know a lot of material there.